it's kind of required. We might need to try. No, I didn't. I'm gonna run it here. No, they're all plugged in. No, that's one. Hi. Go. Just walking and. Come on, Jimmy. You ready? Yeah. Okay. So let's talk about this. Talk about your team, about your project, and anything else you want. Okay?
Okay, is this live or is this?
This is a live, yes.
Oh. Okay, so and we use Florida flight test program. We use to carry flight test equipment aircraft. So typically expensive, but we provide it to use, and it's a lot.
That's when the I'm going to be able to recharge. That is done. The capture mechanism will reach, and then Cerberus is off to do more missions of our system. Cerberus, which is the project we modified from.
Is that currently we don't have with this project. It's not space ready. Tested in a area that simulates that.
It's going to be like more drag, right? Like it's exposing the air. If it's something like this, you know, when you have like a continuous thing, just in fluid. So if the separation is delayed, separation is delayed, so it's better than the slap like this. So it's creating less drag, same amount of lift, but when you put like lift to drag ratio, the ratio is much more compared to a normal wing. You have to reduce drag. We don't want drag.
But it worked out.
No, everyone can exchange like different angles. So
yeah, no problem.
Hey, I'm Brian. I'm the team of this project. Good. And then who's the other guys? What's his name again? Abdul? Yeah, Abdul. Yeah. So you know, as long as we don't just hear, I'll be able to talk to you guys. Actually, I didn't know.
The whole system doesn't fit. See? Found it cool? Good. Which one is the best to fly? Which one is the best to take off? Found the best angle configuration around the planet. We did like extra testing.
You know what? Honestly, I wouldn't be
to find out which are velocity it is.
You're trying to get skin.
Optimum angle that is like 50 degrees the best angle.
This whole thing.
multi-tool rover, which has a tool exchange of 3 tools. The grip objects and grabbing the storms. So electrostatically to the brush would help us remove. This bit is from was mounted a carbon fiber and a limited degree of freedom aluminum arm, controlling and tool operation. And the other, the tool exchanger, which needs an additional degree of freedom, so we actually have another value for both $200 with fully, but the benefit of is that they can increase the mission lifespan by having that built-in. The other rovers can still operate. And they have actually a communication system, a peer-to-peer communication system, and they have several joint tasks where with the motor meshing port, like I explained before, or with the emergency deployment systems, they can cooperate to make Martian exploration that much more dependable in the future. Thank you very much. Thank you.
Yeah. Oh, okay. I'm sorry. I thought you were. Yeah. I just wanted to see the car because we meet you. My name's Nikhil. In front of you, and it gives you on the basis of that you build a. We had this year was to go down on weight, reduce our weight, because of always being bulky, really always big at competition, things like that. This time, and big Mahalakum. So this time we actually have. There you go. Okay, so the last year have reduced. And this car is the interview that I am super proud of. Weight in a year is a great 26% weight reduction. That's great. High school is exposed to it. Course is equal to has the same engine, 10 horsepower. So you limited. That's what we've been done as by 26%, so that we can get a gradual rise. I have another guy, Jordan. Can I steal you for the back here? Excuse me.
My name is Kayla Herga, and using the ECG and all of these signals, like the typical two completed so far, on in each one.
There you go.
Moves around, you want them similar, so this is.
How you doing, mate? Doing good. Well, I gotta go.
So we need you to talk about your project and explain it and your team and everything. Is that okay?
Yeah.
Okay. Go ahead.
Are all of us allowed to? Okay, it was originally built by Benthos, which was purchased by Teledyne. It was built back in the late 80s, and he was then brought to Woods Hole Oceanographic Institute, where they used him for a lot of oceanic surveys and sensor data. He fell into disrepair, ended up with us because he wasn't working, and in 2014 we started doing our troubleshooting process to figure out what was wrong with him. So he worked their communication system with 2 airplanes on thing. So from design the communication system working. So that's again was to communication system to communicate this motors inside the equipment, but for our university to use to conduct research, and that came for rated information on the Series A loads physically to be able to utilize. It's about the essentials of our project. Thank you.
So I have.
I don't know. If they still talking to the judge. I think I saw this one.
Hello, my name is Nathaniel Dodgeworth. I am from the Electrical Income Project. This is a fully autonomous CAN bus network that is for the detection and mitigation of dangerous environmental hazards that can occur inside vehicles for small children. We have 3 separate algorithms that we mainly use in the detection process, which read the data off of the CAN bus network that all cars have, all modern day cars have. We then send text to the owner of the vehicle to alert them of the hazards that are occurring inside that vehicle. If the conditions aren't mitigated in enough time, we send a text out to the authority with the question.
Thank you guys.
Thank you.
About the idea of a rocket-powered vehicle, suborbital, that could get to the other part of the world, land, and be able to deliver a certain amount. I think that is what is going to be able to speed up the delivery of a maintenance. Now, we haven't gone through on that. Not any project like this. We decided to take on a big challenge. You got what is this senior engineer down the street who's been working on this problem for decades. I started seeing about 20 minutes of time. No one has actually deployed it. I think P35 has some of that. Flight control
project and your team and what's going on here. And that's
okay,
like
cool. Yeah. Do you mind?
I'll talk to you tomorrow.
Thank you. Sounds good. Do you mind being at the single? It's easy. You want to step aside? You guys, I have to do. You guys, I'm about to film. Okay. Sorry. All right. Ready when you are. All right. Hi, I'm Brian Casati. I'm the team manager of this morphing, and this is what it's basically is a redesigned airplane flap system for drag station. There's two main components we're looking at. The first one is the current airplanes today are using a lot more composite structures. This leads to the same structure of aircraft, bending and torsion and things like that. We use a redesigned flap system where it starts from the fuselage going all the way to the tip, and it's able to, so if there's any type of bending or deflection that's happening in the wing, the flap is able to consider, the flap is able to make minor corrections to ensure that it stays like structurally stable without any like major instability. The second component we looked at was the variable, different degree, kind of like a twist and turn. And so a piece of paper, like a standard airplane flap is just very flat, and so if you look here, there's going to be this much area of drag from the wind that's hitting it. If you're able to create a curve for that, what happens is that there's going to be less area, so there's going to be less drag, but you're going to be at the same angle of attack, as you can see here. So you'll be generating, you're going to lift, but reduce them. And so those are the two main components of our project. The final part is it's a redundancy system. Basically, we have multiple flap sections that are able to function independent of each other. If one of them were to fail or two of them were able to fail, then one surrounding will be able to counteract and ensure that the flight stays successful. Good analogies like Falcon 9s, rockets or whatever, they have 9 engines at the bottom. If two of them fail, the same idea. Again, this is better than traditional aircraft because they have 3 flaps on them. And that's pretty much a good explanation of the project there.
Cool.
Good?
Yeah. Thanks, man. Appreciate it.
I did them wrong. Yes, sir. Hi.
We are from TV, so we need you to talk to us about your project, about your team and everything.
Absolutely. How long do I get? 4 minutes? Yeah, I can do that. It might be a little long. There's lots to talk about, though, but I'll do my best. Do you have just you want me to give a general? Go. Just want to talk to the camera or to you, either one. All right. Just want to make sure. I'm a video guy by trade, so I want to make. Good?
Yes, sir.
All right, fantastic. Hello, my name is Zach Hibbert. I am the project manager for Florida Tech's NASA Robotic Mining Competition team. And this year we are building a robot for the 2008 competition. And the cool part of the competition is that NASA pulls in teams from all over the country and asks them to build autonomous robot to mine simulated Martian regolith or Martian dirt. And for this year's competition, the rules have changed on us. And instead of mining just the powdery material on the surface, we have to get more gravel. The rules of the competition are pretty simple in that we operate on a fixed field up at the Kennedy Space Center. Our robot has to traverse from one side of the field to the other, mine the regolith, and return to a collection in the field, and deposit at least 1 kilogram of the material. The more material, that's just to qualify. The more material you get, the higher the points you achieve. We are also graded on things like how autonomous our vehicle operates. And full autonomy meaning that it can complete the entire process within a 10-minute time period, completely without human interaction. Essentially, we turn it on, it does its operation, completes a task, and shuts off on its own. Other rules include we have very specific weight limits, series length and width, and we're also graded on dust prevention. We're also graded on certain higher level or certain meta things about our project, including a systems engineering approach. We have to submit a systems engineering paper for the project as well as discussing certain events that we have to schedule throughout the semesters about how we are engaging the local community in biomedical fields. Like or computer science, as I'm also a computer science major. I don't know if you wanted to see the robot real quick, but over here we've decided on a pit ladder system, which looks like a giant chainsaw. Very happy to get that way. And what it will do is it will tilt using linear routers and actually dig into the ground and down to where the gravel lies, 30 centimeters down, and dig up the gravel. And we have some. We were able to complete a prototype test earlier this year, and we were successful. So really looking forward to having good success in the competition based on our design, and also have because we're on a very tight budget. Also have very specific weight requirements. So it has to be under 80 kilograms. So we're trimming weight wherever we can to maintain
stability in the structure. The software runs on an NVIDIA Jetson TX1 board, which is like just it's basically a small onboard computer. It will take in the autonomous system, if it can get it to work, will take in data from a Z stereoscopic camera. Stereoscopic cameras are much like the ones used on most modern 3D films. It takes two lenses and is able to retrieve distance data from the object we are looking at. And I don't know if you can see in the distance, or the object we're going to be using for object recognition, the big green-looking pyramid, or a four-sided die. If you're familiar with dragons, it might be recognize that. But essentially, our camera will be able to recognize the object and be able to tell us what side of the object we're on, the distance we are from that object, as well as the orientation of the robot on our field, and from going from the starting position of the field to far side where we need to mine the regolith. And we also have our manual control is, and from there we're going to a laptop which will process those commands, map them to certain operations, send them mostly to the robot, and then the robot will process those signals and translate those into machine instructions. I.e., when you press forward on the Xbox joystick controller, it will send the forward signal, one signal every second, to the robot, and the robot will then send those signals to the wheels to trigger them to move forward at a certain time. And as soon as you let off, it sends a sound again, and then will stop. It's a very simple system with a lot of complex communication going on in between there, because once the autonomous system is implemented, it will also need to send signals in place of the manual control to those wheels. And what we don't see here is a delivery system, which we have yet. So the delivery system will be implemented after Showcase, where we have a ramp that will catch the material and sift some of the powdery regolith, just the gravel that we need. And then we have a delivery belt that will be able to, with teeth on it, that will collect the gravel and be able to dump it into the bin. So I said we start from our location, go to the next location, the mining arm, then into the ground, 50 centimeters down, collects the gravel in our collection bin, which will be on the back here, and then collects our amount right now based on just amount of time and our estimates about how much gravel per second that we can mine. It will back up all the way across the field to the dumping bin and right up next to it, and then the delivery bell will activate and dump the gravel into the bin. And we're hoping to get at least 1 kilogram because that's what we need to qualify. And the competition starts on May 14th, so we don't have a lot of time, but we've come a really, really long way. I'm really proud of the progress we've made so far.
We have last one.
We studied quorum sensing effects with Kleptomonas reynardii. It's a phenomenon we found that it includes some broader. Therefore, we wanted to size of 15,000 tracks would allow us to study nutrient deficiency going on here as well. So we found there is some low molecular weight for the motility increase in. Thank you.
So my name's Caroline. I'm Carell. And the fertilization pathway. And so what we know right now is what you can see right here. Basically,
years colonize Mars. In your habitation space, you don't need to worry about how you're going.
Uncoordinated 19 is really activator, but it also activates neurons and sensory things that are really important in the development of an embryo. Maybe it would be part of the probability that it's in the egg. When I ran the RNA against that high to do my own real life transcriptome.
Only in the skin, melanocytes, which is that makes it much than to other organs growing normal cells. We looked at that pathway to go through a database to approximately then onto both drugs into the lab, found which cells are on, go ahead and
where age of the egg and the other one, and then later on the equation 1. So we are tried on if you want to create it into the lab manual with the clinical VR project and lab machine learning individual student that each student could possibly which will be also presented on 4th. Thank you.
Take one from me now.
we should interview him. We should. I mean, I can, but we don't record.
This one?
I want you to go out there. Okay, Dr. McKay down there. So we will give you this and go interview him.
To Dr. McKay?
Yes.
I'm not dressed for it.
No, it's fine.
You sure?
Yes, yes. We did that in the morning, so you are fine.
Oh, you didn't dress up at all?
It's working? Okay, I would take it there. Can you like brief the camera more? Sage. Yeah. So put this here. Okay.
Can you hear me? Can you hear me? Can you hear me? Can you hear me?
Wait.
And where's Dr. McKay?
You see him? You see the guys with white shirts?
Yeah.
He's there.
Okay, and I'm just asking him anything about the
Yes,
expo?
yes, say, take one of this.
Okay.
And say hi, Sage, FITV. and our camera is there, so we will zoom in, and you can talk to him.
Okay.
Okay.
And am I asking him anything specific or no? No?
Yeah, ask him about the
Ex-
showcase,
yeah.
how this important for the student, how this important for the school,
Yes.
and what your opinion, what you think,
Okay.
what your opinion about the project.
About the what? About the budgets?
Yeah, about the budget, what you think?
Oh, okay, project, got it. Yeah. So go ahead and walk down there now.
Here's the thing.
So I guess I can just go down now and you guys will be ready by the time. Oh. Ooh, wrong one. Your friend's here. Hey, Tessa. Interviewing. I have to interview people. Can you hear me? Can you hear me? Oh, that's a cute shirt. Can you hear me?
Nope.
Shit, I'm going home.
Can you hear me? You can hear me? Okay. As soon as Dr. McKay is done, I'm gonna go to him. Huh? Yeah, I wish I was about to start rocking. I'm not that good. Is it that tense in here? Not to everybody. I'm getting ready to interview Dr. McKay.
Oh, wow.
Yeah.
Very popular.
Apparently. Dr. McKay, hello. So my name is Seju. I'm with FITV. Can we do a quick interview? Do you have time for the channel?
I have to show him
One more project, and then we can just ask him about the event.
Well, that's up to him.
Okay. All right. Thank you.
Thank you for your help.
after one more project. One more project.
Yo, what's up, man?
What's good, man? How
you
you
know
doing?
when they're starting the ceremony?
I do not know when they're starting the ceremony.
Oh, you look like you're emceeing it.
I was supposed to be emceeing it, but they replaced me.
Really?
But it's all
Did
good.
you dirty like that?
Yeah. It is what it is. It's because I'm a student.
Oh, okay.
Yeah,
I see what
yeah,
you're
yeah.
saying.
So we'll see what happens.
All right, man. All right.
Yeah.
Chill.
All right, man.
Second one. That one over there.
Did you do a project? I said, did you do a project?
Yeah, I'm thinking I thought that was a guy.
Which one?
The thing.
You talking about the suit?
It's not the suit, but like what's on it.
Oh, what's on the suit?
Yeah, we just put it there to like display where we will want the things to be. So like people are getting distracted by the suit, but like like it's worse if we just put things on the table and just tell them like this should be there. So we just put it on the mannequin. That's basically it.
You guys think you presented well?
Honestly, I don't give a shit.
Did you have a project? Oh. So what do you guys do instead of like this nonsense?
Me?
Yeah, for people in your like space.
I did senior design actually. I did senior design already. I made a film.
Of what?
I made a film about the senior design process. We did some research talking to people on various teams. And we had some interviews. Like, it was like kind of like a feature film. And we had a spot here. And the judges talked to us for like coverage purposes and like things for marketing. And things like that. So I was the director of photography. What are you doing? Are you doing something for a YouTube channel or?
Not for my YouTube channel, for YouTube channel. But
Have you interviewed anybody?
I just got here. I'm supposed to be interviewing Dr. McKay. That's what they want me to do.
He's
But-
probably at the awards ceremony.
No, he's here. But I tried interviewing his bodyguards. His bodyguards are like, no. He has to see one more project.
I haven't seen it. He has bodyguards?
This lady and this guy. Like
the lady like with curly,
Yeah.
like, very like blonde hair.
Yeah, her.
That's his like direct secretary.
Yeah, like
she's like his scribe. Like you never see him like for a public or like official function without her presence, no matter what it is. I could probably count on one hand the number of times I've seen him without her. Now, the thing is, once he was just like walking down the street.
Yeah. She was like, oh, it's only like she has to do one more project, and if he wants to come back and interview, then I said, come on.
Her job is literally to make sure that he doesn't have to say no to anybody because she's doing the no's.
Yeah.
Like she's job is like to say yes or no for him.
Can you hear me? Can you hear me? Can you still hear me? Can you hear me? Can you hear me? Can you hear me? Can you hear me? Ooh, excuse me. In the back? This one. Right there. Ooh. Okay. All right.
Am I talking to the camera?
Yeah, we're talking to the camera.
Yo.
All right, so my name is Seju. I'm with FITV. Nice to meet you too. Okay, so can you briefly describe to me, in a quick synopsis about what your project is and what, inspired you guys to do what you guys are doing?
Yeah, of course. So this is the Formula SAE project.
Okay.
We're based off a competition that the Society of Automotive Engineers gives almost 500 schools from across the globe.
Okay.
What our school does, we compete in Michigan against 120 of those schools, and it's the most competitive field. And at the end of the year, right after graduation, we drive up to Michigan and we compete in 4 dynamic events where we're actually racing the car, and 3 static events where we're actually talking about our engineering decisions and why our car is why we made the engineering decisions we made and why it's the fastest that it is.
Okay, and have you guys already competed already, or are you guys wanting to compete in the future?
Yeah, so our competition is like it's the same thing, same event every year. It starts May 9th and it goes to May 12th. So yeah, that's right after finals week and after our graduation. Yeah, we transport our vehicle to Michigan, and our first testing time. So the engine is fully operational, and we're going to be testing the vehicle for the first time next week, next weekend.
And you said that this happens every year. Has there been a year that you guys won? 1 year, or are you guys like second or third, or like what is it?
So the competition. Well, personally, like I love this competition just because it's so fierce. We compete against schools that are from Germany, from Japan, Korea, South America, all over the place. And a lot of the teams, they have much bigger budgets and much better facilities. So most of the time, the teams that are in the top 5, 10 are usually the teams from Germany, the teams that have sponsors from Red Bull, Mercedes, Porsche. Yeah, there's a lot of high quality teams, but we're definitely on our way to being on that tier.
All right, well, thank you for your time.
Thank
Again,
you.
my name is Seiju, and just for the camera, just say I love FITV, okay?
I love FITV.
There we go. All right. We're here. Who's in charge? Who's in charge of our whose project, or whose project I should say?
That's team lead.
Team lead?
Yeah.
Well, I guess I can talk to any of you guys. All right, so my name is Seiju. I'm with FITV, so we're going to be talking to that camera right there. All right, it's for our live stream for FITV, okay, on YouTube. Nice to meet all of you guys. All right, so just briefly, could you guys tell me what you guys' project is and maybe what inspired you guys to do what you guys are doing now? So anyone can take the floor.
You want to start us off?
So we're FIT Chaos. So we were working with Harris to design the thermal and power management system for a 6U CubeSat that would house a high power capacity payload inside, and we had to manage the thermal regulation of the system and determine which subsystems inside will turn off and when they need to be turned off so that the system all stays in the proper temperature range.
Okay, so you said the project was given to you by Ares. Was this something that you guys were looking into because you guys were fascinated with launching something into space, or was it something that was like a need and so they wanted you guys to take care of it?
So actually, Dr. Bourne, who is one of the professors on campus, is actually working on research for this project, and we basically just caveated on the power and thermal management for that project.
Okay. And so how successful would you guys say that you guys got into reaching your goal when you guys first started the project into, like you said, with the thermodynamics and trying to consolidate everything? Did you guys reach that? Did you guys get to do what you guys wanted to do?
Yes, we were able to achieve our goal of properly managing in the proper thermal ranges for everything in the system to operate.
Okay. All right. Do you have anything to add into it? All right. Well, just for the camera, one time, say I love FITV, okay?
I love FIT TV.
All right. There we go. Thank you, guys. I appreciate it. Thank you. All right. Can you guys hear me? Can you guys hear me? Okay, all right. Hey guys, how are you? Hello. All right, so my name is Seiju. I'm with FITV. You guys mind if I do like a quick, interview with you guys? All right, so just quickly, tell me what your project is and what inspired it.
Our project is using, do I need to look at the camera?
You can look at
Kinda
me.
Kinda awkward.
No, you can look at me, it's fine.
Our project is a chemical plant that uses waste cooking oil to produce biodiesel and propylene glycol.
Okay, and what inspired the project? Did you guys just one day you're like, oh, I want to do this, or?
Well, the inspiration actually, our team leader is very interested in biodiesel, so it started with that, and then an advisor suggested finding something novel to do with the waste product that also occurs with the biodiesel, which is glycerol. That's where the propylene glycol comes from.
Sounds good. And was there any complications or what was like the major complication that you guys had when you guys were doing this?
Our major complication is probably when trying to simulate the process. We use a simulator called Aspen, but not all of the components that we need are in Aspen. So we had a little hiccup there. So we've been using a lot of Excel calculations and a little bit of Aspen here and there to try to figure it all out. But it's working well enough.
That's good, that's good. So Excel was able to power the computation that you needed to do when you guys didn't have Aspen you said it was? All right, and was it more tedious or was it going to be the same amount of work being done, or was it faster or?
Honestly, it's probably about the same amount of work. Still got to figure out all the math that Aspen usually does for us, but Aspen asks for a lot more inputs, so it's probably about the same.
All right, well, thank you guys very much. Again, my name is Seju. Just for one time for the camera, just say I love FITV, okay?
It's I love FI. What is it?
FITV.
I love FITV.
All right, thank you, thank you. What time is it? Ooh, 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 ooh. Can you see me? How's it going, guys? All right, so my name is Seju. I don't know if either you or anybody of your team. So there's a camera right there. We're just going to do like a quick interview about your project, all right? Is that fine with you?
Alrighty. You want me to do it or y'all want me to do it?
I mean, you guys can join in. It's all good.
All right, Bijan, he's doing a camera that's going to come and record us, so me and you should probably use that for people to talk about this. Got you. Let you know.
All right, so while we're waiting for him, all right, that's the camera again. My name is Seju. I'm with FITV. So if you could just tell me quickly what your project is and what inspired it.
Okay, well, we developed a crash detection system for motorcycles. The inspiration came from our client and our team lead, Bijan Adams. He got into an accident about a year ago, and he realized that luckily he didn't get hurt, and he also had access to he had his cell phone on him. It wasn't dead, so he was able to call people for help, and he realized, and if he was not able to do that, if his cell phone was damaged or was dead, he would have been in a really bad situation. So from that inspired him to come together and try and make this product a reality. He's very innovative. He's always making products. So when he came up with this idea, he talked to Tyler, another one of our group members, and then he contacted the rest of us. We made a team and we made it into reality. So this crash detection, this device that we made efficiently will detect a crash if a user has experienced a crash, and if so, it will send their personal information as well as their last known GPS location to a SARSAT system, which is a global and international system that doesn't require any cellular
no monthly fees.
Yeah, no monthly fees, no cellular.
It's a government-run network of satellites.
Yeah.
That's a free service to anybody. So initially, it extends out to hikers in case they get lost in the woods. And so, we wanted to transfer that technology to a motorcycle. So if you're a dirt bike rider riding in the forest, if you're a jet ski rider riding in the ocean, if you're a cruiser that takes long trips, we got you covered.
Yeah, it'll be able to determine that. And we also have it so that even if you were to, so what happens is the SARSAT system picks up that signal. They then contact first responders closest to you. So it takes 3 to 5 minutes for the SARSAT system to get that signal. They send it to first responders. So depending on how close you are to the closest first responders, whether it's fire, fire squad, police, any of those kinds, then they can get there within 10 to 30 minutes, depending on how far they are. So it provides a safety net to motorcyclists. And most motorcyclists, as you know, they're not it's considered the most safest. They're living on the edge in general. So we wanted to provide them with some sort of safety net, knowing that if they were to ever experience an incident, help would be on the way. They wouldn't even have to worry about pulling out their cell phone. They know that help is on the way.
And the average response time from the time the signal is set. Oh, you got it?
Yeah.
Okay.
And just one more thing. What would you say was the biggest complication when you guys were trying to build?
Hardware and software.
The hardware and
Alright,
the software?
so
But
we
what
had
specifically?
complications everywhere,
Okay.
man. I mean, we had hardware obstacles, we had software obstacles, we had organization obstacles, we had teammate obstacles.
But at the end of the day, we realized that compromise and communication
Yeah.
is the only thing that would allow a team to develop what they really want to develop. Wasting time trying to blame someone else for something else, a hardware
gets you
team,
nowhere.
hardware blaming the software and software blaming the hardware, it will, as much blame as you place, it will never get the product done. So we realized communication, we got to be open to everybody's opinions, and then we got to compromise. Make it happen, understand what can be done, what can't be done, and make it happen.
I specifically remember a day when we're sitting in the lab, the whole team, and we had an I2C trouble issue. And, you know, of course, hardware team is saying it's software issue. Software team, of course, is saying it's a hardware issue. And we were probably sitting there for maybe 4 hours arguing with each other until finally, you know, we said, you know what, guys, we're hitting our head against the wall. We're going nowhere. We're not doing anything productive. Let's go get some lunch. Let's call it a day. We'll come back tomorrow. We'll figure it out tomorrow. And actually, that was the best thing we could have done.
And we're not even going to say which problem it was, which way. But, yeah. Either way, you know. Yeah.
Well, thank you guys very much. Again, my name is Seiju. Just one time for the camera, just say I love FITV, okay?
I love FIT.
All right, thank you guys. Appreciate it. So I'm walking around trying to figure out who I want to do, but I think everyone is gone, getting ready to go to the ceremony. So this is it. I should photobomb. What do you guys think? Photobomb the photo. All right, so we're gonna walk around the photo people and definitely smile at them. All right.
It is supposed to be driven in a profitable right? So and then the main thing that we did, I see you there.
What's up? Well, yeah.
How you guys doing?
We're good.
Good. Yeah, so you guys have like maybe 2 to 3 minutes that I can take from you? All right, so my name is Seiju.
David.
Nice to meet you guys. My name is Seiju. I'm with FITV. So quickly, can any of you guys just quickly tell me what your project is and what inspired it?
Alright, so our project is SAE Baja. As far as what inspired us, well, it's a national collegiate competition that's repeated yearly where we do kind of like an off-road racing ATV type of stuff. And a big part of our competition is building a car that's durable enough to withstand jumps, bumps, concrete and wood obstacles like logs and stuff.
Do you think you succeeded in that?
Oh, absolutely. This year we had an amazing project. We cut our weight down by 26% off last year's car. Last year was way over-engineered. And the year before that, they didn't even go to competition. So we did an incredible job this year, dropped 134 pounds. And man, in automotive, whenever you drop 4 or 5 pounds, you get promoted. You know, we dropped 134 pounds. Whole team came together. Chassis, we dropped 74 pounds. For our competition, the engine's set. Everybody uses the same engine. So name of the game is weight reduction and getting the most power out of you can out of that engine. So we made a lot of strides this year. It's a great time.
So from this year compared to last year, what did you guys do to take off that weight, that 127 pounds that you said?
So we completely redesigned the chassis. Like I was saying earlier, the chassis was completely over-engineered last year. And our chassis guys did a lot of great work on that. Cut 74 pounds in the chassis. We went with a different type of transmission. Just going to powertrains, different type of transmission. Went from manual to a CVT, which is continuously varying transmission. And a double gear reduction system. So what the CVT does is it continuously changes the gear ratio based on the engine output to kind of get the engine operating at the optimum torque band. So that was a big change. Dropped 15 pounds on that. New tires, new rims. That's 20 pounds right there. Yeah, went with aluminum rims compared to the steel last year. New carbon fiber seat. New steering system, lightweight steering system. Dropped 6 pounds on seats, 3 pounds on the steering system. New rack of pinion, dropped 4 pounds off that. Really just lost weight wherever.
Nice, I like it. Well, thank you very much for your time. Again, my name is Seiju. Just one time for the camera, just say I love FITV, okay?
That up there. I love FITV.
All right, thank you very much, man.
Appreciate it, brother.
All right, you too.
But this isn't air pressure.
You have the time.
3:37.
All right, thank you. Did you guys hear me?
Man,
Did you guys hear me?
Oh.
Really? You guys heard me? Wait, were you guys really able to hear me?
That's a lot of hissing, but that's
A lot of
about
what?
it. Hissing
Hissing from who?
from the connection.
Oh, I thought it was me. I was like, I hiss.
No.
Did you guys see me?
Yeah, we saw you.
In the people that were interviewing.
Can you see where all the joints are? Like, look in your pocket.
No. Should I put it in my waist?
The Gleason.
They're going to Gleason?
So let's go there.
Okay.
Okay.
When's the ceremonial thing over?
At 4.
Is that 4?
So you will go there and interview if we get the chance.
Okay. I gotta make one quick pit stop and then I'll meet you guys there. I gotta go tell my GSA that I'm not coming to live.
Okay.
All right. Where do you want me to put this?
Wait. Ooh.
Be right back. You said Gleason, right?
Yes. Hey. No, you're not out. Not yet. We need you.
I don't have the mic though.
So we will give you the mic now.
Okay. I was getting ready to go tell. That's fine. I'll just email them. My GSA.
Sure, he will understand.
Yeah.
I wish if you've been here in the morning.
Yeah, I had an exam.
Fuck exam. This is important.
Says the one that is about to graduate. I'm not about to graduate. I still have years left.
Okay.
I really wish that I wanted to dress up, but what?
And the film festival, you need to do the same thing.
Okay.
Also on the international food
On
festival
Monday.
live.
Oh, do I need to dress up on Monday?
Yes.
Okay. Okay. I should have dressed up for this.
Lose connection on the way there, but let's go.
What are you working on today?
Me like 5 times.
When, today?
Yeah.
When are you done here?
When I'm done.
Okay, and I'll come see you.
Okay.
Okay?
I may not be home.
But you don't have to be home.
No, like I'm going somewhere. So.
Okay, well text me. Let me know.
Okay.
All right.
Bye.
See you. Fair enough. Fair enough. All right. Yeah, you shouldn't start at the gym. All right. Lift it all the time. Can't even see my face. I can see now. This project that you guys are doing before we all start.
We were doing Project Typhon. Oh, we are still doing Project Typhon.
All right. Can you tell me just in like maybe a sentence or two what it's about?
Since here there was Project Cerberus.
Okay.
They were actually the project that won within the aerospace department. We are making an interface for a mothership that connects Cerberus with that mothership.
Okay.
And then so mothership is Typhon, and we're making the interface between the two. And then that is able to refuel and recharge Project Cerberus.
Okay, so what are some improvements that you guys made from last year's model to this?
We're not improving it. We're creating a trading ship. Yeah. And what happens is Cerberus eventually runs out of fuel. So what we do, we connect the two of them. We have our project capture Cerberus, connect, and then that connection transfers fuel, well actually cold gas, and then another connection on the bottom transfers electricity. So it refuels the tank and recharges the battery.
What would you guys say your biggest improvement was?
One of our biggest things was to put Cerberus back together, because after Cerberus finished their delivery over the summer, someone improved their thrusters, another researcher, and then left Cerberus on its own. We had to reverse engineer all the code, put it back together with the help of a couple of other people, put everything together, and then within the interface of the two, the connection was kind of having everything to be able to be aligned so that we were able to complete that connection.
Alright, just one more question. You guys built a was it just smooth sailing all the way through?
Yeah, so most of the time we were on schedule and on time with what we were delivering, whether it was a CDR project or CDR documentation or it was a physical product. What we needed for senior design was basically entirely made, which was just getting the capture system to work and properly dock. As we move forward into the next month, we'll also be going to UCF to present another showcase. For that, we'll have service fully functioning and our system entirely fully functioning and do a full test for that. So I think right now we're in a very good position, and I think throughout the process we did have our hiccups and we addressed those, and I think that we either continue our project or we can get publishing of the rendezvous and capture system between Cerberus and Typhon, and hopefully do some cool things with that in the future.
Alright, well thank you guys very much. Just one time for the camera, just say I love FITV, okay?
I love FITV.
Alright, thank you very much. Felt about the whole event?
We're NASA G and we feel really good. I think we have a really cool project, and I hope the judges thought so too.
You guys, one time for the camera, just say I love FITV, okay? I love FITV. We got like a big group. 1, 2, 3. I love FITV. Alright, thank you guys very much. Alright. How you guys doing? My name is Seiju. I'm with FITV, the school's media group. So you guys are spectators here. Are you guys here for anyone specific, or are you guys just here wanting to watch?
We're here for someone specific.
Who might that be?
That might be our son. Would you like to know what project he's doing? He's doing the water recycling program.
Thank you guys very much. Alright, just one time for the camera, just say I love FITV, okay?
I love FITV.
Thank you guys very much. Alright, let's go outside and back around. Alright. Guys, how are you? My name is Sid. One time for the camera.
You got FITV.
Well, you know, it's interesting because our students get better looking every year. They really do. Except I did notice a couple that aren't quite up to standards, but in general, much better, much better. You know, next time I have a student town hall twice a semester, and so far the maximum attendance was 35. So next time I want this whole group there, would you? Except the only one when I did have 35, it was sort of like a hanging party, and I was the guest of honor, so it wasn't as much fun as it might have been. You know, when I did my senior, we actually did a senior thesis, and it was, but we didn't have teamwork. You did one totally by yourself. And in some ways you learn a lot, maybe a lot more, but what you don't learn is how to really function in today's world. There is no such thing as the lone wolf anymore doing their work by themselves, or maybe a tiny number of them. And so if you can't work together, if you can't work in a team, if you can't participate as a member, then you're probably not going to succeed in your chosen career. And every time I talk to employers around the country, they all comment on how well prepared Florida Tech students, new graduates are to work in their company because they know how to work in teams. And this is the experience that you have. You've been working on this team for at least a year, and you've produced some unbelievable results. It was so difficult to say who should win an award.
Thank you, Dr. McKay. We will now proceed to the category awards, which recognize the best project in their individual category. These awards are presented by Dr. Marco Carvalho. The Best in Show for Biological Sciences goes to Investigating the Housekeepers of the Cell, Molecular Chaperones at Fertilization. The Best in Show for Biomedical Engineering goes to Heart Phones. The Best in Show for Chemical Engineering goes to Production of Acrylic Acid from Glycerol. The best in show for chemistry goes to biomimetic synthesis of beta-cyclodextrin pegylate nanogels. They will be back for the award later. The best in show for civil engineering and construction management goes to design of the Constellation Museum. The best in show for computer science goes to a robot. Can you get my paper from the printer? The best in show for electrical and computer engineering goes to Moto Beacon.
Feels good.
The best in show for marine biology, ocean engineering, and environmental sciences goes to modular operated pontoon. The best in show for mathematical sciences goes to optimization and algorithmic approach for PCB assembly. The best in show for mechanical engineering goes to Scuff Protection Interface SPI project. The best in show for physics, astronomy, and astrophysics goes to Spec Tracer. The best in show for sustainability goes to Sustainability Advanced in Campus Dining, including increased organic food options. This year, we're introducing a new award category, the Outstanding Award in Design and Innovation. This award recognizes to life. The winner of this category is Heartphones. We now invite Mark Nichols, Technical Fellow of Systems and Software Engineering at Northrop Grumman Corporation, to help us present the Northrop Grumman champions.
Thank you. On behalf of Northrop Grumman, in particular Jeff Grant, who is our executive sponsor, also a Vice President of Space Programs, and how many people here know about the James Webb Telescope that's going to launch next year? So you all know it's going to look back 13.4 billion years in time? Yeah, it's phenomenal. So on behalf of Bob Klein, who is our Center of Excellence Vice President, and as well Jeff Reed. Don't tell him I said that now, Gretchen. Jeff Reed is our executive coordinator for Northrop Grumman. All the work that you guys do is years. Some of us have been here. David Iodice has been here all 10 years. You know, his comment was, every year it just gets better and better. I'm completely impressed with the integration of the teams, the diversity of the backgrounds of the teams, and how well you guys work together. You know, when you all become engineers and scientists in industry, that success will determine your career, right? That is, so you guys are knocking a home run as best I can tell, and I'm proud of you all, so keep it up. With that, I want to introduce the two presenters here. Ryan Howie. You know, I knew I'd, you look at that spelling, and been with Northrop Grumman for the last 2 years. He's a graduate of FIT, undergraduate in aerospace engineering, and completes his master's here in the next couple of weeks and defends his thesis, and I believe graduates May 5th. So hats off to Ryan. I know he's He's a superstar in our company and well respected, and hats off to you, Ryan. And Melissa? So I have an interesting story about Melissa Pumphrey. Melissa is a long-term Northrop Grumman employee. She's been there 2 weeks. She completed her degree, her undergraduate degree in ocean engineering in December. And did I get that right? Oh, I'm sorry. That was the master's in instrumentation in December, but her undergraduate degree was in ocean engineering. She works as a mechanical engineer, and for those of you who know about aircraft, she's working in instrumentation of orange wire, which is critically important in the early stages of flight test. So I expressed with her just the opportunity that she has to learn and grow. It's such an important area as we collect all this data in our, ground tests, low-speed taxi, high-speed taxi, in our first flight. It's an amazing opportunity. So she's going to be presenting science, and I can tell you, in sitting in that room, that this is not an easy. Many discussions and many debates, and for the winners, congratulations. And I think Ryan's going to mention a couple honorable mentions, but if we could list them all, we'd be here too long. So with that, Ryan.
I have to say what an honor it is to be standing up here today. 4 years ago, I was sitting out there. Actually, we did it in Clemente back then, and it's much better in here, so good job for that. I was in your guys' seat 4 years ago, and we were fortunate enough to actually take home the Northrop Grumman Engineering Award that year. And to kind of come back 4 years later, and Gretchen said, "Hey, Ryan, would you be okay with handing it out?" I said, "Yeah, I'll be okay." On the inside, I was screaming. I was like, "This is so exciting." Every year, I come back and see these projects, and this is the third year of judging that I've done this. And I don't even think our project would hold up in this year's competition. It was seriously some amazing engineering and science that so impressive. And like Mark said, it was a really tough decision to come down to our top award. And having said that, I have some honorable mentions I want to talk about. The Cross Stitch Studio, that was an amazing project. If we can get a round of applause for that project. One of the things that we pride ourselves on at Northrop Grumman is innovation, and that was just a project that was an original idea and something that we really, really liked. Moto Beacon was another one that we really, really thought was a great project. One of the biggest challenges in engineering is the documentation. A lot of times that you have, these drawings and all this stuff to keep track of. And we were really impressed at the professional approach that team took, the documentation, and the way that they presented their project. And finally, in aerospace engineering, Typhon was another impressive project that we saw. So, good job. There can be only one winner, and after much debate in the back room, we kind of had to pick one. And this project was a solution to a problem that's actually been around in all of human lifetime. And they came up with a solution that was completely viable. They tested it, they proved it, and the way that they conducted themselves, and I know that they overcame some challenges along the way, it was very impressive. So the winner of the 2018 Northrop Grumman Award in engineering is sustainable water recycling.
expressed, I'm very proud to be back here as a Florida Tech alum. I was blown away by the projects, and like he said, it was a very, very tough decision. It was a lot of back and forth. I do want to give an honorable mention as well for the science category for melanoma gene analysis. It was interdisciplinary applied research, and we thought it was really impressive. However, okay, yeah. Our winner blew the judges away with her great presentation skills. She had a very strong hypothesis. It was, you could see the passion behind what she was doing, and we hope that she goes on to future development of what she did her research in. And so, Altair Dubai for molecular chaperones at fertilization.
Now I would like to introduce the president of Florida Tech, Dr. Dwayne McKay.
Okay, now for the big ones, the ones with the trophy, and you don't get to keep it, by the way. You can walk around with it a little bit, but you have to bring it back. And but your names will go on a plaque that goes actually on the trophy itself, and there is a plaque for it. You know, since my degrees are in science and in engineering, I can never make up my mind which one should be announced first. So you made it up for me. You just handed me the one, and this is science. The President's Cup 2018, the award for science, the President's Award, is investigating the housekeepers of the cell, molecular chaperones at fertilization. And I guess that would be referred to as the Triple Crown, right? So she won a little bit of everything. Now, for engineering, and you know, I personally found this one to be quite intriguing. It's a really great piece of engineering work. I think it's going to have a payoff downstream. It's really important. And it's one you haven't, I'm not sure we've mentioned it before, but the President's Cup for 2018 in engineering, Scuff Protection Interface Project. Just one more remark, and that is, you know, you saw quite a few young women step up here today, and we're going to have more and more. That should make the young men even happier, I would think. So So congratulations to all the young men and all the young women that won awards today.
Finally, I'd like to thank everyone for attending and supporting all the outstanding student projects today. See you next year.
You can hear me now. All right, guys, really quickly before you guys all disperse. All right, so my name is Seju. I'm with FITV. Congratulations on you guys' award. Very, very proud of all of you guys. So just quickly, just tell me how you guys feel about winning these awards. Any thoughts, concerns?
Overwhelmed, excited, yeah.
Really proud.
Very excited.
All the hard work paid off.
All right. Hello, Missy. How are you? Again, my name is Seiji. I'm with FITV. I know you're getting bombarded, but quickly, can you just tell me how you feel for our viewers on YouTube?
I'm pretty amazed right now. I didn't think I'd get one award, not to mention all three. I mean, it's amazing. It's really a great opportunity, and I'm happy to be here, and I'm happy to have presented my research today. So. Well, I think it's really just the faculty here are amazing, and they make you want to do everything. They make you want to live in a lab, or at least for me anyway. So that's really what I spend my time with, and I really work closely with my research advisor, Dave Carroll. So, this award kind of goes to him too. So.
Hello guys, how are you? My name is Seiju. I'm with FITV. Congratulations on you guys' awards. Very much. All right, so quickly, one of you guys to speak. Just tell me.
Number one, it's lit. It's lit. It's lit. It's been a lot of hard work this semester. Each of us have probably put in 40 hours, 50 hours in a week at times, and so it's deserved, as someone said. We didn't see it coming, but here it is. So just take it as it comes. It's a blessing.
Absolutely, it is truly a blessing. So tell me.
Really thank everyone for giving us expected. I think this project could be implemented later on for other uses as well.
All right, just one more question. Do you guys have any plans for what you guys did for the future? Do you guys want to implement it in some other areas? And if so, what are some of those areas that you guys want to push your project in?
Well, I think that's why we won, because of the applicability of our project. Our project is designed to be an open source manual that we actually doesn't stay in the senior design center after we graduate. It actually gets implemented, and that's how it was designed. That's how we intend to carry on through, get it implemented and get it to make a difference.
All right, well, thank you guys. Congratulations again. Hello, sir. How are you? My name is Seiju. I'm with FITV. Could you just share some thoughts about the event and tell me why this is so important for our students for their future careers?
Well, the first thing we have to see is that they are getting a hands-on education besides the theoretical aspects of the classroom. So that is our main component here. We really want to encourage hands-on research for all of our undergraduate students, and this is the way we do it, by having a showcase, by having them prepare a capstone for senior design, and by awarding them for a job well done.
Absolutely. And of the people that won, what was your favorite project? I should say?
They were all my favorites. I've seen them grown for the past 12 months, so I couldn't pick one, even if I wanted. That's why I didn't pick the awards.
Absolutely. All right. Thank you very much for your time. Can you hear me? Is it bad?
A lot better.
Was it? How was it before?
Don't hold this, just hold the mic.
How bad was it?
Quite bad.
Damn. Okay. What do you guys want next?
I don't know, but I need to go around.
She scares me.
Microphone is bad?
Yeah, not better. It's not connected. Hey, come here.
I know. To who? I already talked to them.
Oh, okay.
I talked to both of them, yeah. I think we're good.
Wait, she said okay.
What about those people outside in the blue? Right there with the award in their hair.
Okay, who do we need to get? Are we getting her?
No.
If not, just close. Like, thank
Close.
you guys for watching.
All right. All right, well, thank you guys for watching the award ceremony today with us. Again, my name is Seiju. Thank you guys for tuning in with FITV. This was an amazing event, and we are very grateful for all the innovation and thoughts and ideas that went out today here at FIT. All right.
Are we good? Thank you.